Well, thanks so much, Laszlo. It's really interesting to be here. And I think that's a good place to start. Why would I do this? And this actually started off because there was a study done on rats last year that showed that if you deprive rats of food, so the opposite of hunger, then they will regenerate their stem cells and redevelop their immune system. And so if you starve rats for 5 days, they regenerate parts of their immune system. I was like, cool, I should try that. So I didn't eat for 5 days, I only drank water, and then I noticed something interesting, is that when you stop eating, and you start thinking about food. And I also wanted to draw an XKCD plot. And what was interesting is that I started thinking so much about food that I decided to do a project about food. And I Googled, and sure enough, Laszlo's paper came up, and he had kindly released all of his data, which was a collection of recipes. And so I set myself a deadline that by the end of this 5-day fast, I would have to finish this project on food.
And did you?
Yeah. That makes the first baby steps towards this bigger scheme. And since then, I've been thinking more about the motivations for this kind of project. And I think there are two interesting motivations to tackle a project about food and understanding food and building a recommendation system for food. And the first I want to discuss is decision fatigue. This is a phenomenon in social psychology where if you give humans more options, you make it harder for them to decide which option to pursue in their life. And in the context of capitalism and the supermarket, this means that we're overwhelmed with choice, so that even if we want to make healthy choices, it becomes harder and harder. And so I run into this myself. I struggle with this. I want to eat healthy, but I always eat the things I love. And those aren't the healthiest all the time. So this is one aspect, decision fatigue. We want to solve the problem of decision fatigue. And another aspect is familiarity. I took this picture at home over the holidays, and this is my fridge. And I just thought it was funny. This is before this project, because these are all the foods that make me happy, all the good Estonian foods. So there's whole milk, there's pickled cabbage, pickled herring, there's potatoes, lots of bacon, good, healthy, fatty foods. And so this is the other tension, because we want to explore, we want to eat healthy, but we also want to be comforted and eat things that are familiar. And so what I hope you take away from this talk is that there is a way to resolve this, and there are well-studied methods for resolving this tension. And my friend started working at Spotify, and it turns out Spotify's already solved this problem. If you've used Discover Weekly, it's a music recommendation service, and I think it's the best recommendation service deployed to a large number of people. And in the next few minutes, hopefully I can give you an understanding of how the algorithm works.
Interesting. So 2 of our former lab members work for Spotify in the data science team.
Oh, cool. Yeah, you should ask them about this.
Yes.
It's really cool. Because it ties into networks.
Yes, they're network scientists who were hired. And,
oh, wow. Very cool. So they probably know about this. So this is, the idea behind Discover Weekly is to look at the statistics of co-occurrence between songs on playlists. And this is where I'll introduce the idea of representations and learning high-dimensional embeddings or vectors for items that we care about. So we want a high-dimensional representation of things. And in this case, we want a high-dimensional representation of songs. And so what Spotify does, they have this strong signal source, which is playlists. They have millions of playlists, and songs co-occur on playlists. And what we can do is build a big matrix of songs by songs, and then for each entry, fill in the number of times, like say Lady Gaga has occurred on a playlist with Justin Bieber, and then that'll be the entry there for that part of the matrix. So you have this big matrix of co-occurrence counts, and what you do then is singular value decomposition. And so you learn a low-dimensional embedding, and it turns out that is a fantastic way to encode meaning according to these co-occurrences. And another way of phrasing that is through a multinomial logistic regression. So if you assign a high-dimensional representation to each song, and then ask that representation to get really good at predicting the songs it occurs with on playlists, then you'll achieve a similar effect. These are two ways of saying the same thing. And what you do after that is pretty straightforward because you've achieved your goal of having this high-dimensional representation of songs because you've trained them to get good at predicting which songs they occur within playlists. And then you take all the songs you've listened to in the past week, take their average vector, and then do cosine similarity. And that is discovered weekly. It's a really simple algorithm. You could implement it in a few lines of Python, and it works really well. And what's awesome is that food follows a very similar pattern. Instead of playlists, we have recipes. And here's one of my favorite recipes. This is Filipino pork barbecue.
That's good.
The ingredients are vinegar, 7-up, pork, soy sauce, pepper, brown sugar, lemon, and garlic. And let's see how this algorithm works that I just explained in words. So this is multinomial logistic regression, and we'll take the embedding for vinegar, the first ingredient, and then ask it to get good at predicting the rest of the ingredients, or the context. And it's slightly different than multinomial logistic regression because we're also going to randomly sample ingredients or other items from the vocabulary, and then ask vinegar, the representation for vinegar, to be really good at not predicting random ingredients for the vocabulary. So what you're doing in this high-dimensional vector space is pulling closer together these representations and pushing farther apart these representations. And hopefully this is intuitive because things go together, things co-occur on playlists or recipes, and random things should not be close together. And here I just scrolled through and picked random ingredients, and vinegar maybe should be close to fresh tomatoes, but on the whole, random things will be far apart.
So this is what you're saying is vinegar is not individually close to this full list or to any of the ingredients in that list?
So this is just one step of the algorithm,
Yes.
and then you're going to change the numbers in each dimension,
Okay.
just a little bit, let's say 0.01, according to an increase in the log probability of these context ingredients.
So when
So
you
you're just
say
taking
vinegar,
tiny
so this
steps.
is vinegar, the highest probability of occurring vinegar is with 7-up? No.
No, there's no, the order doesn't matter here.
I see, okay.
Yeah.
Okay.
And you do this for all the ingredients in your data set.
Mm-hmm.
And so in this case, we had maybe 100,000 recipes, now we have 200,000, and you go through this, and after this, you have a high-dimensional representation of your vocabulary, or all of your foods. And after that, you can do all the basic statistical things and explore the results, such as averaging. And so the average embedding of a recipe will give you a representation of the recipe. So in this case, the average vector for Filipino pork barbecue skewers will be the average of its ingredients. And you can do the same thing for users. So this says that the user is equivalent to the average of their favorite foods, which in this case is Filipino pork barbecue, smoked salmon, and natto.
Question, is it really so?
Sorry,
Are we the average of all these different choices?
that's a good question.
Thank you.
Yeah. This is just one way of computing a user representation.
No, I'm just saying that is,
you
so
have
it's a
evidence?
good representation. So anyone tried anything else? So a different combination of this.
I think they must have internally at Spotify,
Mm-hmm.
but this is my understanding that the average works pretty well.
Okay.
Yeah, and this is what I'm trying to test right now to see how well the
Sad.
average works. Yeah, but I agree, there must be better ways like weighted averages, because what I think is bad with an average is you might end up somewhere in the middle.
Exactly.
Exactly.
Exactly. Or think about the fact that you're representing the ingredients and the recipe as the average of the ingredients.
Yeah.
What about the cooking process?
Exactly.
Okay.
Yeah. Or you could think about weighting each like doing a weighted average where the weight is given by the popularity.
Mm-hmm.
Because you have an issue with, like, say, salt and butter and things that occur frequently, having a really large
Or moreover,
representation.
dishes with similar ingredients but different cooking processes are going to be exactly the same.
Exactly. Yeah. Yeah, these are all good points. Definitely lots of follow-up work. And then you can also look at other things like natural language processing techniques. And so this came from looking at these embeddings on the English language. And it turns out that you can do analogies. So by subtracting the representation for man from king and adding woman, the closest vector to this vector will be queen. And so this notion of analogy works in English, but I don't yet know how good it is for food. I'll show you some demos and you can judge. And let's see if this works. So this is just a low-dimensional representation of the food embeddings. And what's interesting is that these labels were not used in the training process, but the ingredients separate out according to which cuisine they're from. And so here we have a taco corner with tortillas, salsa, cheese, things like that. Here there's an Indian corner, peas, dal, masala. And so it was interesting for me to play around with this and see what kind of patterns are present from learning these high-dimensional representations.
So I'm curious, is Estonia to Northern European or Eastern European?
That's a good question. I would say Eastern European.
Okay.
Yeah. Like potatoes, sausage, cabbage.
Okay.
Yeah, less so Northern European, which I
But
think.
do you see a distinction here? Because you have the Northern European, Eastern European label. Are they together?
Yeah, so what I found interesting is that the data is pretty biased. So there is an overrepresentation of North American and European foods. And so I think what will be necessary in the future is to have a lot of foods from every different cuisine.
Yeah.
And what's interesting also is that if you see European and North American foods are kind of all over the place because they're the cultures with the most influence from other cultures or other parts of the world with the most immigration.
So what are the dimensions here? Like how do you explain the distance between 2 points?
So here, don't read into the distance at all. The distance is just to look at it visually. It's an algorithm called T-distributed stochastic neighbor embedding, and it's looking at the Kullback-Leibler divergence between a Gaussian kernel around each high-dimensional data point. And we can also look at similarity. So, Leshla, what did you eat for breakfast?
Oh, geez, coffee.
Coffee.
Actually, I had a banana.
It's not
A
breakfast.
I had a banana,
Coffee
yes.
is not breakfast.
Banana, yes.
So it says the most similar to banana is fruit, and then green is fruit. So this is reasonable.
Yes.
And if you also notice that when you click this button, there's a slight delay, and that is a key tip for designing user experiences because these embeddings are only 100-dimensional and it's really fast to compute, but it added a delay. And it makes it very satisfying. So let's try it again. So what are some analogies that you can think of? I need help with this. I still don't have a good understanding of what is a food analogy. So I gave this example, like egg is to bacon, orange juice is to coffee. What should we try?
Pizza is to tomato, I don't know.
Pizza.
Tomatoes to bit.
Pizza crust is to.
Tomato.
Just a question. So you don't have a, let's say, a completely free choice here. You have a selection. So
Yes.
Yeah.
okay.
There's a
So
vocabulary.
what is your regional database?
It's the same data that.
Okay,
Lashla
so the
was
same
talking
flavor
about.
one.
Yes. And I'm slowly working to expand that. So pizza is to tomatoes as
Bread.
bread.
Oh.
Bread is to. Alright, wait for the delay.
Chocolate.
So it's yeah.
Plum.
Interesting.
Maybe that's plum tomatoes, and you have.
Oh, maybe. Yeah, maybe I
Yeah,
didn't
good point.
calculate the vocabulary correctly. Macaroni. Let's see. Also chopped tomatoes.
chopped tomatoes.
And then there's also this. So this is going after the idea of taking the average of a bunch of ingredients and then trying to predict which ingredients it should go with. And what's your favorite recipe at the moment? Let's try it.
Don't look at me.
Let's see. Noodles,
Noodles?
pork,
Noodles, pork.
And let's try ramen, dashi broth, D-A-S-H-I.
Oh my god.
Dashi.
Yeah,
Dashi powder.
dashi, just the
Just
upper one
dashi.
probably. Is
What's
enough.
that?
And
Dashi, that should be enough.
okay. And here it says you should add sesame seeds, seaweed. Is that reasonable?
Yeah, that's reasonable because those are the base ingredients for ramen. So
Oh, okay, cool. So I guess yeah, sesame seeds go on ramen, seaweed goes on ramen.
Yep.
So there's some. It's not perfect, but there is some high-level patterns that it can capture.
And here you are using only the recipes, right? You're not using the flavor ingredients.
No.
Not at all. I
Yeah.
see.
And I
Okay.
think that would be really cool.
Yes.
To explore doing
We have
that.
much more you can use actually probably there, but at the end talk about it.
Yeah.
No, because actually, so this embedding that you're building is just related to, so you learn from the recipe.
Yeah, it's only co-occurrence of foods and
Exactly.
recipes.
So there is also the flavor part, the chemical compound part that is missing right now.
Yeah, that would be really cool. Because we could also embed flavors and then do the same thing.
it's gonna go into molecular food earlier.
No, please.
And then this is a browser I tried to build. This is 100,000 recipes, and the same technique. And then you can kind of see high-level patterns that European foods are kind of all over the place. Let's see, there's some South Asian foods here. And these are just the ingredients in the recipe. Like you could compute the average embedding and then do this projection and then kind of browse. And so you see North American foods are really overrepresented. They're this pink part here. And what's interesting is that the Asian foods cluster together, kind of as you'd expect. There's lots of overlap, but they're pretty dissimilar to North American foods. And so I think there's some interesting high-level patterns here. But I think also I haven't found another way to browse this many recipes at once.
So each node is a recipe here, right? Or
Yeah, so I don't have the URL, but you could imagine just adding the URL and then
Uh-huh.
browsing a large collection of recipes.
Do we have in the database the URLs?
I scraped more data.
I see. Okay.
Yeah.
Alright.
It's all, so this is all live right now, just the URLs, and so you can check out the GitHub, all the code is open source, all the data and scrapers are open source. And so I'll jump back and tell you some more about other statistical techniques. This is a demo, and now we can apply other techniques from statistics to understand further the patterns that we learn in these embeddings. And if you remember the training process, then we computed a conditional probability of an ingredient occurring with another ingredient. And you can do this for all ingredients. And then you can look at complementary items, and in this case, we've defined it by their mutual probability is high, like their conditional probability of predicting each other is high. And here's some examples of complements found through this method. So both of these, their conditional probability of predicting each other is high. And some make sense, some make less sense, but on the whole, I think it's decent. Sesame oil goes with soy sauce, mulatto chilies goes with guajillo chilies, kimchi goes with gochujang. And
So
another,
does it mean that, for example, the probability of having coconut and red curry is as high as red curry with, like, you were just saying?
that these are
Either
the
way.
highest out of all other ingredients. And another thing you can do is look at substitutes. So if you look at all ingredients, you'll get a large probability distribution over all ingredients. If you use the vector for ice, for crushed ice. And then you can look at the KL divergence between these probability distributions. The Kullback-Leibler divergence just measures the number of bits that these probability distributions differ by. And then intuitively, this will measure substitutes. So what foods induce similar distributions over the items.
So these are replacement items, right?
Exactly.
So,
Yeah. And so intuitively, you expect the KL divergence this distance between probability distributions to be higher for ice and crushed ice than for crushed ice and beans, because they predict very different sets of ingredients. And here's a list of substitutes generated. This seems like a harder problem than the complements. Sometimes it gets it right, like taco seasoning mix can be substituted for taco seasoning, ice cubes for crushed ice, but definitely don't substitute melon for gin.
Why is melon?
Yeah.
If you have gin, right?
Yeah.
So it's definitely interesting to explore this, and also this doesn't seem like a good substitution, boiling water and hot water. So I included, yeah, sorry.
But your methods take into account the order it appears in the recipe, or
No.
just the
No,
presence?
it's all unordered.
Okay. So I was thinking that ice cubes and crushed ice are not that similar, because when you use crushed ice in recipe, you are using it for the texture.
Oh, interesting. I didn't know that. That makes sense though. Yeah, so I just added these to illustrate that there's lots of work to be done. Sometimes it works, sometimes it doesn't, but it's definitely fun to play around with. And so here's some things that I'm working on now. So my friend has a collaboration with an app called Lose It. It's a dieting app. People record their diets, and then we're testing this to see how well it performs for recommending recipes to users. And what I'm really excited about is the possibility of using substitutions for healthier items. So if you know someone's been eating a lot of bad stuff, you could just say, hey, why don't you use less salt, or substitute, I don't know, soy sauce
Bacon
for
for
salt.
tofu.
Yeah, bacon for tofu.
Is that live?
No.
It's really hard to change that.
Yeah, it seems like a really hard problem, but we'll see how far
So
we
have
get.
you guys heard of food switch?
No.
You will.
You
Create
will.
it on the back as
Oh,
well.
yeah. I'm excited to hear about it.
Yes.
And yeah, here are just more ideas. So I think also the user interface and user exploration is in the very early stages, because I don't know much HTML. I did my best on like the browser, but I think if you have like a designer or a UX designer, it'd be really cool to build this into websites or recipe browsers and explore the possibilities. And yeah, as I mentioned, the code is on GitHub, so feel free to run it. It runs pretty fast on large data sets in C++.
Does it have the delay built into it?
Yes. 500 milliseconds. And feel free to send me an email about any of this. I'm happy to chat anytime. And if you're interested in technical details, then we're hoping to publish a paper on this in the next few months.
Cool.
Thanks so much.
Questions?
Thank you very much. Besides the helpfulness, the tastiness is important. And I wonder if it seems that a lot of the clustering is the commonality of the foods that go together. I've just, as someone who cooks at home, come across this sort of genius recipe cookbook that I have found extremely useful. And each of these recipes is sort of regarded as like almost an instant classic. And I wonder if there's a way to build in sort of a hierarchy of, not just sort of the recipes sort of in block, but boy, these recipes kind of wowed people. With combinations that were maybe unexpected. Because I feel like I would face far more decision fatigue looking at that sort of last, boy, that's a million recipes.
Totally.
And I do little things at crib notes and like the recipes I want to sort of do over the next month or two or whatever. But there's something about the quality of the recipe that matters to me a lot, and it's sometimes the same ingredients but a slightly different technique. And so I'm wondering if you might be able to sort of, next iterations.
Yeah, that would be interesting. I think there's proxies for that. Like if you imagine doing this like for a website like the New York Times or All Recipes, then they have rating information, and like the very first step is just doing like a Discover Weekly analog, where you're just recommending like 3 recipes that have high ratings that this user is likely to enjoy. I think that's the first step. But what was the name of that cooking?
It's called Genius. It's food2vec. It's
Food 52
a
Genius.
website that publishes cookbook. It's a lights out cookbook, right?
Yeah. But it's also, another point is it's interesting to define the notion of unexpected flavors, because you have this probability distribution over foods, and then what is unexpected? Like, is it high entropy, or is it just really low conditional probability? Like, is it something random? I think that's definitely to be explored, or adding in flavor information to the foods.
So the IBM folks who did Watson Chef, I know have considered a lot of these issues. Like I know they were focused on the surprising combinations that turned out.
Do you know how they
good.
measured that?
I don't. And it might be secret sauce type stuff, but
Actually, they came here and gave a talk once, but it was a long time ago, but I don't remember how they did that.
I do know that they would create networks of foods based on recipes.
Cool.
But it would be interesting if to reach out to one of them or just try some of their online demos and see how they do.
Yeah,
They-
totally.
They did actually have a food truck staffed by a chef
Oh,
where
I
you
remember
type in
this,
your
yeah.
ingredients and then they'd make a recommendation and the chef would try to come up with a way to actually make it. The chef would come up with the recipe, the machine would come up with the ingredients.
Interesting. Yeah, that, we definitely need something like this.
Everything else is clear. Thanks a lot. Thanks again.